The Arctic is changing rapidly under climate change. The Greenland ice shelf is melting. The sea ice extent is decreasing. We need Arctic observations. The sea ice has become much more mobile and drifts faster. These changes can be observed in detail using satellite remote sensing. The microwaves used in satellite remote sensing cannot observe the inside of the ice or the internal of the ocean. To measure properties of the sea ice or the temperature of the ocean under the Arctic sea ice, we use instruments placed in the ice or in the ocean below the ice. Such measurements are needed to get the better knowledge about how fast and how much the Arctic is changing. The INTAROS 2018 field experiment North of Svalbard, we collect data about the atmosphere, the ocean and the seismicity in the area. The field operation is carried out with assistance from the Norwegian Coast Guard using the icebreaker KV Svalbard.
When the ice starts melting, the surface of the Earth will start moving upwards again, and this causes the buildup of stresses which can lead to increased earthquake activity. So we know that there are earthquakes and other natural hazards in the Arctic. So in addition to earthquakes, we also see landslides, we see submarine landslides, we see tsunamis and other types of events.
Most of the earthquakes are occurring offshore in the Arctic, but seismometers and the stations that monitoring the earthquakes are based on land. This means there is a huge gap in the observation system in the offshore part, and in INTAROS we try to fill these gaps by putting instruments in the ocean bottom.
This will allow us to record more earthquakes, but also to have better locations of the events that we are recording, and thereby to understand better the processes behind these earthquakes.
Good morning.
I did my PhD in University of Bergen. This is my first cruise.
My field of study is light in the ocean, how light behaves. One of the most important things that influences light in the ocean is life in the ocean.
When I was doing my PhD, actually I focused on UV radiation, so nothing to do with ocean or water. I cannot swim. Actually, I'm afraid of water. We are mostly interested in the optical properties of waters.
And the Arctic Ocean is quite different from other oceans around the world. You know that there will be a certain amount of improvisation, and if something doesn't work, you can't just go to a store to buy something new. Science is about either doing new stuff or finding new knowledge. Only the last maybe 10 years that you really started to see observations of under ice algae blooms. Phytoplankton are like the forest of the ocean. How these plankton are give certain optical properties to the water. So it decides how much of the light is scattered and how much of the light is absorbed.
We have tested different types of water in different locations on the Earth. We bring instruments to the location and then we put the instruments down to desired depths, and then collect data there, and also bring back water samples.
Then we look at what happens with the light as it passes through the water. So for example, we look at how much of the beam is lost on the way to a detector on the other side of the instrument.
So we will know the absorbance, and we know the weight, we know the concentration of chlorophyll A, and then we analyze the filtered water.
So the light can be used to monitor the life.
This project is specifically about the precipitation that fall into Norway, especially the snow. To better understand how much precipitation we will get, we need to look at the sources of the water. We have huge reserve of fresh water in the Arctic. To trace the origin of the water, we have this specific water tracer, which we call Delta 18. Yes, I'm inside.
And then we have the isotopes down here. That's what we really want to know. It's telling us where water comes from.
A large part of research is just to look at new things or produce new things, not copying what the others have done. So if you go in an area where there is less studies, then you have more chances to do something new.
This task is focused on field work in the area north of Svalbard. We actually call it north of Svalbard towards the deep basin, because the work in this task includes both the shallow area, which is the shelf area north of Svalbard, as well as the continental slope, and also part of the deep Nansen basin in the Arctic Ocean. The Atlantic water can pass into the Arctic boundary currents through the deep Fram Strait, because actually Atlantic water can get into the Arctic along two different ways. It can be either via Fram Strait, or it can be through Barents Sea opening, or the Barents Sea. But Barents Sea is very shallow, and all heat which actually Atlantic water carries along goes to the atmosphere, is lost to the atmosphere already in the Barents Sea, so it does not reach the Arctic Ocean. So the only source of heat for the oceanic heat for the Arctic Ocean is actually the Atlantic water, which goes through Fram Strait, and then around the western corner of Svalbard it enters the Arctic Ocean boundary current. And this is exactly where we are measuring, where we have our moorings, and when we collect our shipboard measurements, also from Cape Svalbard.
We need to understand how the ocean works so that we can be able to better predict how it's going to influence, the climate and the rest of the world in the future. My area of research is marine biogeochemistry. So on this particular cruise, I'm involved in making observations to understand the marine carbon cycle. The ocean absorbs about a third of our atmospheric CO2 emissions, which reduces the severity of global warming. However, this CO2 absorption causes a chemical change in the water known as ocean acidification, which could have some serious consequences for marine life, particularly here in the Arctic. The North of Svalbard is the place where the Atlantic enters the Arctic Ocean, carrying with it such things as heat, dissolved gases and nutrients. In this location, Tor and I will help deploy mooring, which is essentially an 800-metre long cable tethered to the seabed and suspended vertically in water column. On the mooring there will be a series of instruments that will automatically measure the chemical composition of the water, for example dissolved oxygen and carbon dioxide, as well as nutrients and even microplastics. This will be done at different water depths over the course of an entire year. So by measuring these seawater properties north of Svalbard, we hope to have a better understanding of how the entire Arctic environment might change in the future.
Boring is a long line with different instruments which are attached to the line, which is moored on the bottom by a very heavy anchor, and also have some buoyancy, for example a big steel flotation or several smaller glass balls, just to keep the mooring, the line upright. And then to get this line into the water with all these instruments, this is quite a challenge sometimes, especially that we are working with deep moorings, which are, let's say, even 1 or 2 kilometers long.
The ocean in the pole are warming, and what interests us is to know how this heat is distributed in the Arctic Ocean, at the same time how it is fed by the other ocean, especially the Atlantic Ocean, which puts a lot of heat into the Arctic Ocean through the Farm Strait in particular.
If we are talking about climate and global warming, one of the probable reasons of the quick sea ice melting in the Arctic is that the circulation is changing. And to make it short, if there is more warm water coming from the Atlantic coming into the basin, of course it will warm up all the basin and make ice melt faster.
The ocean is huge on a horizontal scale, but relatively small on a vertical. Therefore, the processes taking place in the vertical direction are usually less intensive and much more difficult to observe. These vertical processes are extremely important for the ocean. And we do not quite know how in the Arctic Ocean the heat carried by this Atlantic water is transported to the surface. I used the Rockland Scientific VMP microstructural probe. It is a free-falling device working to a maximum depth of 250 meters. The measurements give microscale profiles of shear, temperature and conductivity. During this cruise, I just tried to measure the mixing processes occurring in the water column and examine whether in the marginal ice zone or under ice cover, the heat from the deeper layers is transported to the surface.
We are contributing to this project mainly by dropping moorings, oceanographic moorings in the water north of Svalbard.
So we have a program which tries to understand the geographical distribution of this Atlantic water. We moor the instrument so they are fixed in space, but they record continuously in time due to limitation of power supply and battery, etc. We have to refurbish the instrument every year or every second year. That means we have to come back, take out the instrument and redeploy them. So that's exactly the work we've been doing here this year.